Let's start with the biggest surprise. Meta and Harvard just released an open-source coding agent called the Confucius Code Agent, built on top of the Confucius SDK. At first glance, it looks like just another AI coding agent, something like SWE Agent or OpenHands. An AI that edits files, runs tests, and tries to fix GitHub issues. But Confucius is doing something very different. Instead of treating the AI model as the star of the show, they treat scaffolding as the real breakthrough. And scaffolding might sound boring, but it's actually the secret sauce. Why scaffolding matters. Real software development is messy. Tests fail randomly. Dependencies break. One small change causes unexpected side effects across dozens of files. Most AI agents fail here because they forget what they already tried. Confucius flips the philosophy. They say, if you want an AI to survive long debugging sessions in real production codebases, the system around the model matters just as much as the model itself. And honestly, that's exactly right. How Confucius SDK works. The Confucius SDK is built around three core ideas: agent experience, how context and memory are structured; user experience, readable traces, diffs, and explanations; developer experience, observability and debugging for the agent itself. This turns the agent into a system, not just a chatbot with tools. Mechanism number 1, hierarchical working memory. One of the biggest problems with AI agents is memory loss. After 50, 60, or 100 steps, old decisions disappear from the context window. The agent forgets what it already fixed, repeats mistakes, and starts looping. Confucius solves this using hierarchical working memory. Instead of one giant chat log, it breaks the task into scopes, summarizes old steps, preserves key patches, logs, and decisions. This isn't just a bigger context window, it's real memory architecture. Mechanism number 2, persistent note-taking. This part is brilliant. Confucius adds a dedicated note-taking agent that writes structured markdown notes, just like a senior engineer would. These notes capture repo convention strategies that worked, patterns that failed, fragile parts of the codebase, and then it saves them as long-term memory for future runs. When they tested this, the second run was faster, cheaper, and more efficient. Fewer steps, lower token usage, slightly higher success rate. This proves that written long-term memory actually works for AI agents. Mechanism number 3, smarter tool architecture. Most agents treat tools like random button presses. Confucius treats tools as modular systems with state recovery logic, structured prompts, and the results are dramatic. On SWE Bench Pro, a strong tool scaffold boosted success rates from the low 40s to over 50% without changing the model. That's huge. The big result. Here's the headline: a mid-tier model with a strong scaffold outperformed a stronger model with a weaker system. That tells us something important. Scaffolding can outweigh model size. Now let's connect this to the second story. Abu Dhabi's Technology Innovation Institute just released Falcon H1R7B. It's a 7 billion parameter reasoning model, and it's matching or beating models 2 to 6 times its size. How? 3 key choices: a hybrid transformer plus Mamba 2 architecture, a massive 256,000 token context window, a smart training pipeline using supervised reasoning plus reinforcement learning. This model can handle extremely long reasoning chains efficiently, without collapsing under attention costs. And the results are shocking. Top-tier math scores. Strong coding benchmarks. Competitive general reasoning. This proves another big theme: smarter architecture and training are shrinking the advantage of large models. Now for the most suspicious update. DeepSeek quietly updated their R1 paper. No announcement. No hype. Just one thing changed. The paper jumped from 22 pages to 86 pages. They revealed the full training pipeline, intermediate checkpoints, reinforcement learning details, failed experiments, hyperparameters. This is basically an instruction manual. And companies usually don't reveal everything unless they've already moved on. With timing lining up around Lunar New Year, the AI community is asking one question: is this the calm before the next DeepSeek release? Final takeaway: here's the big picture. The future of AI isn't just about bigger models. It's about better scaffolding, smarter memory, cleaner systems, efficient architectures. System engineering is becoming the real competitive edge. Now I want to hear from you. Do you think scaffolding will matter more than raw model size going forward? Drop your thoughts in the comments. If you enjoyed this breakdown, hit like, subscribe for more AI deep dives, and I'll see you in the next one.